Hi everyone. We're going to look at decisions in Python. Decisions allow a computer to change what it's doing based on outside output of some sort. So if we have sequential programming, it runs one by line by line, executing one after the other. We're working on conditional, selection, if, elif, and else statements. We're going to work next week on loops, or the week after. Everything we've done has been sequential. We're going to look at conditional. Well, to do conditional, we need something called a Boolean value. It's part of every programming language. Either something is true or something is false. Computers deal with ones and zeros. It either is or it isn't. So does 5 equal 5? Yes. Does 5 equal 6? No. So this is not the equals operator. This is a comparison saying, are these equal? So this is one we will use a lot. X is equal to Y. There's another one we won't use as often. X is not equal to Y. These are all math operators that you should have worked with. Is something we're going to use later on. So if a condition, and a good way to look at this is to look at our first code. Here we go. Oh, nope. Here we have a little picture. If x is greater than 0, we go this way. It's positive. If x isn't greater than 0, we go this way. No problem. Well, how do we figure out if something's odd or even? If x modulus 2, okay, modulus is integer division, and it looks for a remainder. So if our number is 1, modulus 2 is 0.5, we go over here, it's odd. If it's the number 2, modulus 2, there is no remainder, so it's 0, so it's even. That would be how even and odd can be determined in a computer. Let's look at that first program. Even or odd. Here we go. We get input from the user, which is a string, and then we convert that to an integer. If the integer modulus 2 has no remainder, which would be, for example, if it's 4 modulus 2, that is 2 is the result of the division, there is no remainder, then it's even. Otherwise, it's odd. That's what else can be thought of is otherwise. It's either this or it's not. The number is either even or it's not even. That's your basic decision making for a computer. This is a very traditional first game in any programming language ever does. The guessing game. So, we generate a random integer from the random library. That's its purpose, to generate a random integer. We're importing it from the random library because it isn't part of the Python standard library, which is the part that comes with Python. We can import it and then use it. Here we're telling the randint function that we want to get a random integer between 1 and 10, and that's inclusive, meaning it includes 1 and 10. Some languages don't work that way. So we get a random number between 1 and 10, assign it to the variable random num. We get a number from the user, convert it into an integer, assign that to guess. If the guess and the random number are equal, as we compare it, then the guess is correct. Otherwise, sorry, the number is not random. We know if something's inside the decision statement because of the indentions. So this belongs to this guy, this belongs to this guy. No matter what decision the computer makes, this one, since it's clear to the left, is always executed. Well, let's see how lucky I am. We'll start in the middle, see if I get lucky. Oh, nope. and I don't get another chance. I get one chance, and that's all I get. We quite often with decisions make multiple decisions. We get an integer from the user. Whoops, I'm in the wrong program. Just a second. When you make decision with multiple choices or multiple results, this might be one way to solve it. If the grade is greater than 90, we print an A, right? If the grade is greater than 80 and less than 90, we won't print the B. If it's greater than or equal to 70 and less than 80, we won't, and go down the line. So we have to test each one of these. When we have multiple outcomes of a decision statement, we typically use LF. And we don't have that whole extra and testing business, because with LF, if the score is greater than or equal to 90, say it's 95, we print this, we're done. We jump out because it's either this or this or this or this. If it doesn't catch it anywhere here, then it prints F. So this is much better than the other one. The other one's not very efficient. This is a better way to do it. You're rarely going to have more than one if statement. You're going to start out with an if, in between is going to be LF, and at the end, if all else fails, then you get the last one. Oopsie. There, that's it. It prints A, we're done. It did not have to test any further. So it's much more efficient than the other method. Now here's kind of a fun program. Is this a learning experience? Well, yeah, but it's pretty fun. So we're going to do the magic 8-ball. You may or may not want to know what a magic 8-ball is. If you're not sure, Google it. These, again, we've imported randint. We are going ahead a little bit here, and we're using a loop. A loop means that we repeat something until the computer doesn't need to do it anymore. So we're going to go around and around making decisions again and again. So while answer equals to true, well, look at here, answer is equal to true. That means it's going to go forever. Well, it's not going to go forever. Hang on a second. We will see what happens. So we get an input from the user, like, will I be rich? The question goes in here. Uh-oh, look at there. We're going to do random answers. So that's the magic of the magic 8-ball. And depending on which number comes out, we get a different magic 8-ball number. But notice that it starts if, LF, but there's no else. That means that our decision is going to be somewhere in here regardless. Now, how do we get out of the loop? If I don't press anything, I press enter, that means nothing's going through, and that's what this means. That means nothing. So the break allows us to jump out of the loop and finish the program. And now we're done. All right, so, will I be rich? Ask again later. Well, that's no fun. Will I get $1 million? Oh, well, that's good to know. Does it matter what I type in here? No, because the magic 8-ball is going to randomly give me an answer. That's how the magic 8-ball works. When I'm done, I press enter, which puts a string with nothing in it. And there we are. We can compare strings, we can compare numbers. If I just print numbers, it's an empty string. Well, with the while loop, even though we're a little bit ahead, what can we do with that with some other programs? That does mean that instead of only getting one chance at the guessing game, we could keep going and going and going. Well, we'll do that later on. So let's look at logical operators. We saw some logical operators before. How old are you? Most of the time, you can do if, elif, elif, elif. But sometimes you need to compare like this. Is it between 16 and 65? That's what and means. It has to be within this range. Or means that it's either less than 16 or greater than 65. Either one of those will make this expression be true. And that's what this is called. I'm getting all this flippy stuff here. This is called an expression. It evaluates to true or false. So if I put in 32, 32 is greater than 16, 32 is less than 65, that evaluates as true. If I put 69 in, well, that's greater than 65, so I'll say enjoy your free time because you probably retired. If I'm less than 16 or over 65, well, I am either retired or a kid. That's how you can use logical operators getting more than one. Well, let's just see. I am 69. So that means I'm either retired or a teenager, but regardless, I can enjoy my free time.